Now I am going to talk about a new topic that is very important, and linear models with R. Linear models provide foundation of applied statistics. So that way linear models are very important, and I would like to show you first the PDF of linear model. This is the PDF. See, linear models with R, and these are the contents. So I will cover linear model and generalized linear models. This is known as Gauss-Markov setup. This is known as Gauss-Markov setup. Y x beta sigma square I. The Gauss-Markov setup can be rewritten as y is equal to x beta plus E. So here this is termed as general linear model. It is to be noted that y is the vector of responses and x is termed as design matrix or model matrix, and beta is known as vector of regression coefficients. However, sigma square is known as residual variance. I stands for identity matrix of order n by n. The method of least squares is used to estimate. This method states that we will choose that value of beta which will minimize error sum of square, and this was the concept given by Gauss. So error SS is equal to E transpose E, and that is nothing but y minus x beta transpose into y minus x beta, and result is solution to the normal equation defined as, actually we have to differentiate this with respect to beta and equate the first derivative with respect to beta is equal to 0. So we get this equation x transpose x beta hat is equal to x transpose y, and this is known as normal equation. They are normal in the sense that error and x transpose, they are normal to each other. So it is in the geometric sense we are talking of normal equations, not in a statistical sense that it does not have anything with normal distribution. It is geometric meaning of normal equations, geometric meaning of the normal equation. Alternatively, least square estimates of beta is defined as beta hat is equal to x transpose x inverse into x transpose y. If we transfer this to this side, it is x transpose x inverse into x transpose y. This implies that variance of beta hat is equal to where of beta hat is equal to sigma square x transpose x inverse, and its estimate, we put a hat on variance of beta hat. So when you put a hat here in the right hand side, we have to put a hat here because this is the unknown parameter. So this is known as, and the diagonal elements of this matrix are variances and non-diagonal are covariances. Thus standard error of beta is, SE of beta is actually square root of diagonal elements of variance of beta. So that is nothing but standard error of beta, where sigma hat square is equal to resid SS divided by n minus p plus 1. See, p is the number of predictors and 1 stands for the constant term, and that is beta naught intercept, and this is nothing but ms residual, where resid SS is equal to, see this error SS, and what is the difference between error SS and residual SS? In residual SS we put beta hat here, If we remove this beta hat from here, and head from here. So it will be an expression for the error SS, and when we put this beta head, it will be residual SS. Explanations and implementation with R. We will make illustration with FOBS data available with mass package. Mass package is a very famous package of R. Mass stands for Modern Applied Statistics with S plus. A great book contributed towards the development of R and S plus both, and that is by Venables and Ripley. This book is particularly known as Bible of Statistics and Computing. So, its R implementation of this book is nothing but mass package. So, they have defined many data sets, they have included many data sets, and they have defined some functions, some very important functions, and which are part of this package. So, these data sets, FOBs also there. So, I can look into this data set. Here, just use library mass, data is equal to FOBs and FOBs. So, these are the boiling points, and pressure. So, these are the data sets. Okay. Now, to select Y, FOBs, BP, we have selected from FOBs the BP column, and that is Y, and we have selected X, and that is pressure. We are defining X and Y. Then if you make X is equal to C bind stands for column wise binding, C bind 1X, and as per recycling rule, see, X is a vector whereas 1 is a scalar. So, recycling rule tells that a shorter vector has to recycle up to the length of a longer vector. So, this 111 will be recycled up to the length of the longer vector. Then n is equal to n row number of X, and P1 is equal to n col, the number of columns in X. Then XTY, it is nothing but X transpose X. It is cross product X comma X. And for computing X transpose Y, it is cross product X comma Y. And then we are getting beta. So, beta is equal to solve inverse of X transpose X into X transpose Y, and this is nothing but beta hat. Similarly, residual Y minus X into beta hat, this is known as residual. Then RSS, residual SS is equal to sum of residual squares. Then MS residual RSS divided by n minus P1, P1 is the number of columns in X. And then standard error of beta, SQRT, diag, MS residual into the X transpose X. So, this is nothing but SC beta. And then T ratio is equal to beta hat divided by standard error of beta, and P value is nothing but twice into 1 minus PT, because this ratio follows T distribution with the residual degree of freedom. So, we are having this is twice into 1 minus PT, absolute value of T ratio, degree of freedom is n minus P1, and this is nothing but residual degree of freedom, P value. Note that beta is equal to this is beta naught and this is beta 1, and standard error of beta is this, and T ratio is this, and P value is here. So, this way we can get the results, and just I am going to the command line. Here I will just look into library mass. Actually, mass is among the recommended packages. Out of 21,000 packages, only around 25 packages are part of the core software, core R. Core R means the R software which we download from the internet. It consists of only core packages which are around 25. So among those 25 important packages, MAS is also one among them. So there is no need of installing these packages. It is just you have to load the data and functions available with the package, and the command is library MAS. And then we have to load the data of Forbes. Then we can print, see here, this is the data, this is the data. And if we want to view this, Control 2, view Forbes. See, this is the view. This is the view. How many observations? There are 17 observations. And this is the, and if we want to get help, we can use help BP. Forbes. Help Forbes. See, Forbes in the package MAS, Forbes data on boiling points in the Alps description, a data frame with 17 observations on boiling point of water and barometric pressure in inches of the mercury. Usage Forbes, format BP, boiling point, degree Fahrenheit, pressure, barometric pressure in inches of mercury, source Asiatican and S. Wisberg, applied linear regression. So these two books have discussed this data set, the Forbes data set. So we are going to the source, and here see what we want to do. We want to extract first y. We want to define y is nothing but boiling point. So we have defined we have extracted boiling point from the Forbes data, and then we are extracting x from the Forbes data, and that is nothing but press. And then we want to print x. See, these are the pressures. These are the 17 pressures. Now we want to construct a design matrix. So that is nothing but x is equal to C bind, and if we print, this is a matrix in which is having 17 rows and 2 columns. One column which corresponds to intercept is 1, 1, 1, beta naught, and beta 1 is nothing but these are the x values. Then we want to know how many rows are there and row. So if we print and there are 17 rows, and then we want to know how many columns are there in x. So that is P1, and if we want to print P1, there are 2 columns just. So we have extracted, we have defined how many columns are there, and then we want x transpose x matrix. So we are using the cross product function of matrix operations, that is cross product x transpose x, that is nothing but cross product x. So that is xtx. So this is the matrix x transpose x. Actually, it is the beauty of cross product that if we will have only one, what it does, it makes first transpose of x and then multiplied with x. Suppose we have only one x, then it will generate one more x, and then it will make the transpose and it will give the same result. So xtx. So this is the same result which we have got earlier. So this is the beauty of cross product. Control 1. Now x transpose y we want to compute. So here x transpose y, this is x and y. So what it does, cross product, it makes x transpose and then multiplied with y. So x transpose y is nothing but xty. So we have got x transpose x. Now we are trying to get beta hat is equal to x transpose x inverse into x transpose y. So that has been used, we have used solve function. What is the role of solve? Solve is nothing but it makes inverse of x transpose x and then multiplied with x transpose y. So this is the beta. This is beta hat, and beta we are getting, this is the beta hat. So beta naught cap is equal to 155 and beta 1 is equal to 1.90. So these are the two things we have estimated. Now we are going to compute residual. Residual is nothing but y minus x beta hat. So we have defined a new vector residual, and these residuals are RESID, resid. These are the residuals. There are 17 residuals. For each response and each predictor, we have one residual. So we are having 17 residual. Now we are going to define residual sum of square. So that is RSS is nothing but sum of resid square. So we are making square, control 2. We are making square of these residuals, and it is nothing but these are the residual squares, and then we are going to get its sum. So it is nothing but residual sum of square 2.957. So we have defined this residual control and then residual sum of square, and then we have defined MS residual. MS residual is nothing but RSS divided by n minus p. So this is MS residual, and we can compute this MS residual MS resid. This is MS resid, and then we are going to have standard error of beta hat, and we can get SE of beta. See, so these are the standard error of beta. The standard error of beta naught is 0.97927 and that of beta 1 is 0.036. Now I am going to compute T ratio. T ratio is nothing but beta hat divided by standard error of beta hat, and this T ratio, so these are the T ratios. T ratio for beta naught is 167 and for beta 1 is 51. So both are far away from 2, so that means both are significantly different from 0. So now we are going to compute what is the p value, and p value is nothing but twice into 1 minus pt, the probability of t, and degree of freedom n minus p1. This is p value. So we can compute this p value this is almost 0 because it is far away from 167. So it is actually almost 0. So when we compute, we can print beta, we can print SC beta, we can compute t value, we can compute p value. So these are the values we are getting. Now I am going to define what is the estimate of beta hat. Regression coefficient beta 1 hat is nothing but regression coefficient, and that is nothing but, because actually the model is y is equal to beta naught plus beta 1, y is equal to beta naught plus beta 1 into x plus error. So this beta 1 is interpreted as regression coefficient, and that is nothing but change in the response y for unit change in the regressor x. So what will be change in y if we change 1 unit in x, and that is nothing but regression coefficient. Now we can organize these steps into the form of a function, and that is nothing but SLR, organizing simple linear regression analysis in SLR. This is a function which I developed for classroom teaching, just to explain what is. We can organize all the steps in the form of a function named SLR. SLR is equal to function x, y, because we are talking of simple linear regression. So the difference between simple linear regression and multiple regression is that in simple linear regression we have only one predictor. So we are having only one predictor, that is x, and response y. A function which returns simple regression analysis. X is equal to C bind 1x. So this will generate the model matrix. Then P1 is equal to n call number of columns in x. Then n is equal to n row number of rows in x. xtx cross prod x. xty is equal to cross prod x comma y. Beta is equal to solve xtx into xtx comma x transpose y. So this is beta. Residual is equal to y minus x into beta, and RSS is sum of residual squares. Mean sum of squares for residual, so RSS divided by n minus P1, and SC beta is equal to square root of diag of MS residual into solve xtx, and T ratio is equal to beta by SC beta, and P value is this. And our data frame regression coefficient is equal to reg coef is equal to beta, SC beta is equal to SC beta, T value is equal to T ratio, P value is equal to P value, out, return out. So this will be, and we can dump this function as a file name slr.txt. Now we can go into the source code, and I will try to explain these things. See here. So this function we have defined. We can just run these. So we have, now we can dump this to dump, and then source to source it, then requires map to load the mass package, and then we are selecting, we are defining y, then we are defining x, and then we are using m1 is equal to SLR, the newly function we have defined, x is equal to x and y is equal to y, and then we are going to print the result. So here the result is like this. It is regression coefficient of beta naught, and then standard error of beta naught, then T ratio of beta naught, and then P value. X This is the regression coefficient beta 1, and this is the standard error beta 1, and this is the T ratio 51 point. Actually T ratio is nothing but, if we divide this by this, it will be T ratio. Divide this by this, it will be T ratio. So from above output, it is evident that regression coefficient is statistically significant as its corresponding p-value is less than 0.05. So this is all about simple linear regression. Now I shall talk about multiple linear regression. Multiple linear regression. I have named this function MLR. The basic difference between simple and multiple regression is that in simple there is only one predictor x, whereas in multiple regression it must be two or more regressors. We shall write a function to implement multiple regression analysis with two regressors or covariates. They are x1 and x2. So define a function to implement multiple linear regression. Y is the response variable, x1 is the one predictor, x2 is another predictor. So this function returns regression analysis. So x is equal to c bind 1 comma x1 comma x2, p1 is equal to n call x, n row is equal to n row, number of rows in x. Then xtx, it is cross prod x transpose x. Then x transpose y, cross prod x comma y, and then beta solve beta. Actually this cross prod cross prod x is nothing but x transpose x, and cross prod x comma y, cross prod x comma y, it makes transpose of x and then multiplied with y. So it is x transpose y. Since we are giving only one argument, so it will generate another x and it will make a transpose and then it will define cross prod. So we have defined number of rows x cross prod, and then beta is what? Beta is nothing but beta hat is equal to x transpose x inverse into x transpose y. So it is this expression. Actually this solve xtx into xty. So this is xtx. So solve made first invert of the first argument and then multiplied with this. So that is nothing but this expression. So solve beta, and then residual 1 minus x beta, and then RSS residual sum of square, MS rest RSS divided by n minus p1, SC beta square root of diagonal actually standard error. This is beta, and variance of beta hat is nothing but actually it is sigma square x transpose x inverse. So what we do, and its hat is the estimator of this. So what we are doing, we are trying to extract diagonal elements because they are variances, and then we are making a square root. So what we are trying to do is diag of, first we are going to do square root of diag into variance of beta hat. So we have done this expression here. So, and T ratio is nothing but beta hat divided by SC of beta hat. So it is nothing but this one. Out data frame regression coefficient, out round, because this will by default it will give the data frame up to 7 places of decimal. So we want to write we want that output should come to the 3 places of decimal. So dump and data trees we have data trees, and we are getting y is equal to volume of tree, x1 is equal to tree girth, x2 is equal to tree height, then m2 is equal to mlr y x1 x2, and it is nothing but print m2. So it is regression coefficient, then SC beta, t value and p value, So this is all about exercises based on above concepts. Okay. So this is all about the simple and multiple linear regression model. Now, in my tomorrow's talk, I shall talk about scatter plot matrix. The function is pairs. So we will continue this tomorrow.